In this demo, we'll enhance mobile platform security measures. In this demo, we're going to create a password strength education tool using generative AI to bolster mobile platform security. It's generally considered that humans are the weak link in cybersecurity anyway, so anything that we can do to bolster that component of security posture, the better. It's good for so many reasons, including the fact that it raises password security awareness and the need for strong passwords to protect against cyber threats. We use generative AI for tailored advice and engaging educational experiences. Plus, it's scalable and accessible and keeps pace with cybersecurity trends for relevant content. It addresses the growing importance of security on mobile devices, promotes proactive cybersecurity behavior, it's cost-effective, and it also complements the more technical security measures while highlighting the importance of human involvement in cybersecurity. So to get started, I've opened Visual Studio Code and I have a Python script and an index.html template open. We're going to create a little Flask application, and the objective of the application is to create an interactive app where users can ask questions about password security. The app maintains a conversation history with each user, sends this history to GPT-4 for analysis, and displays the ongoing conversation. Okay, let's break down this Flask application code piece by piece. So, first, lines 1 to 3, we're importing the modules that we need, and Flask, of course, is the main framework for building the web application. Render template is used to render HTML templates. Request is used for handling requests, and session is a dictionary-like object that can be used to store information for a specific user from one request to the next. It is a part of Flask's built-in session management. It's typically stored client-side in the user's browser as a cookie. In the code, session is used to store and manage user-specific data like conversation. OpenAI is for interacting with the OpenAI API. And secrets is used to generate cryptographically strong pseudo-random numbers that are suitable for managing secrets like account authentication, tokens, and similar. Next, from lines 6 through 8, the Flask app instance is created. The session configuration is set to not be permanent, and a secret key for the Flask app is set to a random 16-bit hex string, which is used to securely sign the session cookie, which is just security best practice. Next, on line 11, we initialize the OpenAI client. Then starting on line 14, this is the route definition for the main page, and it can handle both GET and POST requests. When the user first visits the page, it initializes a conversation list in the session to keep track of the conversation with GPT-4. That's the conditional statement starting on line 17. This snippet checks if the key conversation exists in the Flask session. If it doesn't, it initializes session conversation as an empty list. Then starting on line 21, if the request is a POST request, that is, when the user submits the form data, it gets the user's input and updates the conversation with GPT-4. On line 26, we call a function to generate a response based on the conversation history, which gets passed to the function as an argument. Next, on line 27, the index.html template is rendered, and it uses the password analysis which was returned with the call in the previous line to the generate password analysis function. Okay, next we have the update conversation function. This function updates the session's conversation history with the user's input. The first line retrieves the current conversation history from the Flask session. The get method is used to retrieve the value associated with the key conversation. If conversation does not exist in the session, it defaults to an empty list. We append a new entry to the conversation list on line 32. This is set to the user input passed to the function. After updating the conversation list, we then save it back to the Flask session. By reassigning the modified conversation list to session conversation, we're making the updated conversation available in subsequent requests. Next, on line 36 is the generate password analysis function itself. It prepares the conversation for GPT-4, sends it to the model, and appends the model's response to the conversation. Next, on line 53, we have the format response function. Now this function formats the conversation into an HTML list, and it also skips the initial system message because we don't need that in the display. And then finally, on line 66, we have the entry point for the application, and note that it runs the app in debug mode. And of course, we wouldn't do this in a production setting. Okay, now over in Explorer, I just want to quickly explain the directory structure here. So Flask looks for templates in a folder named templates by default, and for static content like images in a folder named static. So that's where I'm storing static images, and the templates are being stored in the templates directory. All right, now the second file that I have open is the index.html template. Now this is basically boilerplate HTML, although I do include Bootstrap, jQuery, and some Ajax libraries to help pretty up the application a little bit. So let's run the app and interact with it. And to do that, down in Terminal, I'll type Python, followed by the name of the application, which is Security Buddy Training App. Okay, so now the app is running. It's running on the local host at port 5000. I'll hover over the hyperlink, press Control, and select the hyperlink. Okay, and now the application comes up in my browser. So here's my Security Buddy application. As it says, enter your password, security question, and then press Enter or select Ask. First, I'll ask it if I have a secure password. So I'll type, is this a secure and strong password? And I'll enter my password, which is capital P @ 55W0RD. And I'll just press Enter. Now it sends off the request, and it's conversing with GPT-4 right now. And it comes back with a message from the AI Security Advisor, which is GPT-4, and it says, no, the password is not considered secure and strong. Although it does include a mix of letters, numbers, and special characters, it's a common password that hackers often guess, right? So for a number of reasons, it's not a very secure password. So let's revise our password and ask it if the new revised password is secure. And we'll enter some random characters. Should be a pretty secure password. I'll press Enter. And now it comes back and it tells us that, yes, this password is considered secure and strong. It's long, 16 characters, includes a mix of upper and lowercase letters, special characters, and does not contain any common words. And then it finishes up by reminding us to keep our passwords safe and avoid sharing them with others. All right, well, with that, we have enhanced security on mobile platforms using generative AI. In this demo, we participate in an AI-assisted mobile platform hack. All right, for my demo, I've opened two files in Visual Studio Code. I have my script. It's a Python script named AI-assisted hack, and I also have a network device scan. Okay, going over to the network device scan. This is a simulated scan with a myriad of data regarding a specific device. So in the scan report, I have the scan date, the device type, the operating system, so it's an iOS 12.4 device. So that's probably going to be an Apple iPhone. Then there's device information, including the IP address, the device name, the MAC address. There's network information, device configuration information, installed applications, and security and privacy settings that have been enabled. All right, so now what we're going to do with the Python script is we're going to open that network device scan, and we're going to get GPT-4 to provide us with an analysis and some suggestions on how we can address the vulnerabilities. And we'll ask it for some CVE numbers that will support research into vulnerabilities and exploits related to such a device. Okay, so lines 1 and 2, I import the modules that I need for this particular script. OpenAI is the OpenAI client. On line 5, we initialize the client. Then we get the device scan starting on line 8. Then on line 12, this is where we start the chat session. And here on lines 13 and 14, we're going to check if there's a new user message, and if so, we're going to append it to previous messages so that we can maintain the entire conversation for subsequent queries. On line 22, we return the response and the previous messages. On line 24, I define a print analysis function where I'm going to basically print the content of the analysis. And then starting on line 29, this is where we implement the multi-turn conversation. Line 37 starts the list of messages. So we have the system role, then we have the user content, which is analyze network device scan and highlight any potential vulnerabilities you find. And of course, we feed it the device scan report itself. On line 43, we call start chat session, and we provide it with the previous messages list, and it returns the analysis as well as previous messages, again, to continue to keep the conversation, and then we print the analysis on line 44. Line 46 starts the section of the code where we implement the multi-turn conversation, which will allow us to ask follow-up questions until we're satisfied, at which case we type exit, and then we break out of the program normally. All right, let's see what we get. So down in terminal, to run the script, first I'll type Python. Now I also have to specify the AI-assisted hack Python script, and for the second argument, I specify network device scan.txt. That's the device scan that we explored earlier. I'll press enter to run the analysis. All right, and GPT-4 comes back and it highlights quite a few potential security vulnerabilities. For example, the outdated operating system, Bluetooth and location services have been enabled, VPNs not configured, we've got outdated applications, security protocols, for example, using WPA2 network security, and then it provides considerations for mitigating the threats. So this accomplishes two things for this demo. Number one, it highlights the AI-enhanced countermeasures that can take place. So for example, as an ethical hacker, I'm trying to uncover these vulnerabilities so that we can address them, and GPT-4 has helped us with that by providing several considerations for mitigating the threats that were found. While at the same time, as a hacker, I'm attempting to uncover the vulnerabilities so that if I was a malicious attacker, I would know which vulnerabilities existed and therefore be able to exploit them. So in this case, I'd have a follow-up question. So I'd ask for some CVE numbers so that I can further research the exploits and choose which ones that I want to pursue. So where it says your follow-up question, I'll ask, could you specify some CVE numbers so that I can research these vulnerabilities in more detail? Pressing enter to submit my query. Okay, and so GPT-4 comes back with 3 specific CVE numbers. So on one side, if I'm an ethical hacker, I know the vulnerabilities that exist, I can research them, and I can provide some recommendations for how to address them. As a malicious hacker, at this point, I would have these CVE numbers, and I know the vulnerabilities, so I can pick and choose which one that I want to pursue. All right then, with that, we've performed an AI-assisted mobile platform hack. In this demo, we'll use generative AI to identify and help patch vulnerabilities in a mobile app. In this scenario, we're considering a type of vulnerability that can be found in some mobile applications, namely insecure communication. This type of vulnerability occurs when an app communicates with a server or other network services or over an unsecured connection, potentially allowing attackers to intercept sensitive data. We'll look at this code shortly, but essentially what happens is it's going to use HTTP for communication instead of HTTPS, which means that the data is not encrypted in transit and therefore can be intercepted. Of course, this is a simplified example. In real applications, network operations must always be handled with proper asynchronous methods or libraries. For example, in Android development, properly handling network operations asynchronously is crucial to ensuring a responsive UI and to comply with Android's requirement that network operations not be performed on the main UI thread. We also know it's best practice to use HTTPS and proper SSL TLS on mobile platforms, and indeed on any platform for that matter. Okay, so in Visual Studio Code, I have a Python script open, and I have 2 source code files. One's called mainactivity.java, and the other is activity_main.xml. So let's have a quick look at the source code. First, activity main. For this pseudocode, we add edit text fields for user input. It's a UI element that allows users to enter and modify text. And button is another UI element that users can tap on or click to perform an action. In this case, the XML layout includes a button to send the data. Okay, now the Java code. So this Java code snippet is a basic example of an Android activity called main activity that demonstrates sending data to a server using HTTP URL connection. So let's just briefly explore the source code. So starting on line 1, main activity extends app compat activity class. It initializes an edit text element username field and a button called send button by finding them in the layout using their IDs. The code sets an on-click listener on the send button. So what happens is when the button is clicked, it retrieves the text from the username field and calls the send data method with the text as an argument. A new thread is created to handle the network operation, ensuring the network request does not block the main thread, that's the UI thread. Inside the thread, it attempts to establish an HTTP connection to a hard-coded URL. That's http://brocadero.com/API/send. The connection uses a post method, and the data username is sent in the request body. HTTP URL connection does support HTTPS, but it's up to the developer to use HTTPS URLs. Using HTTP is, again, insecure because it transmits data in plain text over HTTP. All right, so that's the main activity.java file. Now, the mobile app code scan Python script is going to accept a directory path as an argument. Let's just go over the code briefly. Okay, so lines 1 to 3, I import the modules that I need. Then on line 6, I initialize the OpenAI client. Starting on line 9, I define a function called rescan data and pass it the directory path. And that will iterate over all the files in the directory path that's specified. And it will store all the code in a variable called all_files_content. Starting on line 18, I define the start chat session function, passing it previous messages and the new user message so that we can have that entire conversation available for subsequent queries. Then we return the response and the previous messages. Then on line 30, I define the print analysis function, passing it the response. On line 35, I start implementing the multi-turn conversation. And notice on lines 40 and 41, essentially I'm setting up the source code directory and reading that as an argument that's passed in when I run the script. Line 43 is the list of messages. So we have the system role, and the system is going to be a master cybersecurity analyst and researcher. Then we have the user role, and the content there is analyze the following source code and report any potential vulnerabilities. And we also pass it the source code content. Then we perform the analysis by calling the start chat session function and pass it previous messages. Then starting on line 53, we implement the loop, which will allow us to ask follow-up questions until we're satisfied. And in that case, we type exit and exit the program. Okay, so let's run the program and let's see what we get. So down in terminal, I'll type Python, the name of the script, which is mobile app code scan.py. And I'll specify the source directory, which is right off the demo directory that I'm in right now. So I would start typing source src and just autocomplete. Okay, so I'll press enter to run the scan. Okay, and GPT-4 comes back. And first, it gives us a summary of what the code seems to be doing. So it says it seems to be capturing user input and sending it to a server. It says, while the code is straightforward, there are several security implications that must be addressed. Number one, there's no input validation. So it tells us that the code currently does not validate the input received from the user, which makes it vulnerable to injection attacks. Then point number 2, the use of HTTP instead of HTTPS, which is what we discussed earlier. There's another issue with the hard-coded URL. There's potential issues with exception handling and with thread usage. And data security, it indicates that the app doesn't seem to encrypt the data before sending it. So there's more than just the basic HTTP issue. Now, for a follow-up question, I'm going to ask GPT-4 how I can refactor the Java code to make it more secure. And let's see what it comes back with for recommendations. So I'll type, how can I refactor the Java code to make it more secure? And press enter. Okay, so let's see what GPT-4 came back with. So it indicates, here's how you can refactor the Java code to make it more secure. And it actually provides the Java code refactored for us. So it replaces the use of a background thread with an async task, which is more appropriate for tasks that execute on a background thread. It uses HTTPS for secure transfer. It adds code to encode the data being sent in base64, or we could use hash encryption. It separates the task of writing output to the data stream by using data output stream. And it closes the output stream after data has been written to free up system resources. So with this simple little 60-line Python script, we not only had GPT-4 identify vulnerabilities, it also provided refactored code and recommendations for making the entire Java code more secure. All right then, with that, we've used generative AI to identify and patch vulnerabilities in a mobile app.